Hi, Mr. Eaton here, and today we're going to be looking at how to write trigonometric ratios. Well, before we start, I would just like to do a little bit of revision on labeling the sides of a triangle. Over here we have triangle ABC, and angle C over here is a 90-degree angle, which means the side opposite has to be the hypotenuse, and also this side over here is the longest side. So therefore that's also another reason why it's called the hypotenuse. Within our triangle we can see that this is angle theta, and this line over here will be the opposite because it is exactly opposite. If we look across and we see this line over here, it is exactly opposite to where we're looking. Okay, so that's why this line over here would be called the opposite. The third line therefore is called the adjacent line. Okay. So that's how we label the sides of a triangle. Now there are rules on how to write trigonometric ratios. The first one over here would be sine, and then cos and tan. So those are the three trigonometric ratios. So to get sine, we need the opposite over the hypotenuse, or the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. And tangent is the opposite divided by the adjacent. And all of this we can put into a little acronym which we call SAR, CA, TOA. Alright, well let's do the trigonometric ratio for sine. And we know the rule for sine is sine theta equals the opposite over the hypotenuse. So looking at my triangle, I know that this is my hypotenuse because it is the longest side. And if I was looking all the way across over here, I would see that this would be my opposite, and obviously this would be my adjacent. So in this particular example, my opposite is going to be 4, and my hypotenuse is going to be 9. Therefore that is the trigonometric ratio for sine. Now we want to look at the trigonometric ratio for cosine, and we know the rule for cosine is adjacent over hypotenuse. So looking at my triangle, I know that this would be my hypotenuse, and if I looked straight across at this side, this would be my opposite, and therefore this has to be my adjacent. So my rule, cosine is adjacent, which is going to be 5, and my hypotenuse is going to be 7. So that would be the trigonometric ratio for cosine in this particular example. Right, let's look at the trigonometric ratio for tangent. And we know that the trigonometric ratio for tan theta is opposite over adjacent. Therefore this has to be my hypotenuse, and if I'm looking straight across, this is going to be my opposite, and therefore this has to be my adjacent. Therefore my opposite is going to be 3, and my adjacent is going to be 5. Therefore the trigonometric ratio for tangent is 3 over 5 in this particular example.